So for step 1, when we try n equals to 0, so step 2 is our assumption, where we write assume it is true for n equals to k. We move on to step 3, which is where we show or prove we want to prove that 5 to the power of n plus 2 times 11 to the power of n is a multiple of 3. So you can see that I have two values, 5 and 11, both have indices. So for step 1, when we try n equals to 0, we have 1 plus 2, which is a multiple of 3. So you know we start off with n equals to 0. So substituting it in, 1 plus 2 equals to 3, which is divisible by 3. Therefore, it is true for n equals to 0. So remember, for these questions, always start off with trying with n equals to 0. And if it doesn't work, then we move on to n equals to 1. So step 2 is our assumption, where we write assume it is true for n equals to k. That is, when we have 5 to the power of k plus 2 times 11 to the power of k, it is a multiple of 3, which means we can write it as an equation, which is it equals to 3m, whereas m is an integer. So now using this as an assumption, we move on to step 3, which is where we show or prove that this is true for n equals to k plus 1. So substituting in k plus 1 to here and here, we want to prove that this is a multiple of 3. So that is, we want to be able to factorize out a 3 at the end of it. What we want to do is to either eliminate one of 5k or the 11k. Either the 11k or the 5k, it doesn't matter which one you choose. Either way, we're going to get the same answer at the end, but the point is to know that we just need to choose one and stick with that. So here we've just chosen 11k. So we split this into 11 to the power of k and then 11 to the power of 1 there. We know from step 2, 5 power of k plus 2 times this equals to 3m. So we can subtract 5k across, and you can see 2 times 11 to the power of k, which is what we have here, I have just substituted for that. Once I've used the assumption, I know now that what's left over is manipulation of this algebraic equation. And I just have expanded that to become 33m minus 11 times 5k. If we have just 5k plus 1 there, that's really not going to help us that much, because at the end of the day, what we want to be able to do is to take out a 3. And we can't take out a 3 from that. So we know that we have to split that up into 5 to the power of 1 times 5 to the power of k. So you can see now this and this, they're common terms, which means that we can just add that together. So now we have 33m minus 11 plus 5 just gives you minus 6 times 5 to the power of k. And now you can see we can factorize out the 3, and that gives us 11m minus 2 times 5 to the power of k, which is a multiple of 3. But before we do anything, let's double check that this is an integer. So I can't see any fractions or decimals. So yes, we can say, therefore it is true for n equals k plus 1. And the conclusion for this is therefore 5 to the power of n plus 2 times 11 to the power of n is always a multiple of 3. And in this case, it's for n is greater or equal to 0. Because remember, we started off with 0. So important fact with using multiple with two numbers that both have indices is over here, we want to eliminate either the 11k or the 5 to the power of k. So just choose one and stick to that. And remember to always keep an eye on what we're trying to do, which is factorize out the 3, which is why we knew we had to separate the 5 to the power of k plus 1.